Hi guys, today we're going to learn about the exponential functions, the derivative of the exponential function. You learned back in Algebra 2 and Pre-Calculus that y equals log base b of x means x equals b to the power of y, where b and x are greater than 0. Also, you learned that y equals natural log of x means x equals e to the power of y, where x is greater than 0. Now, let's solve the first two examples. E to the power of x plus 1 is equal to 7. If you remember from Algebra 2, what you were doing, you were applying the natural log to both sides, okay? Kind of like this. Then you know that these two are inverse functions, then you have x plus 1 is going to be equal to the natural log of 7. Therefore, since I want to solve for x, you have that x is going to be equal to negative 1 plus natural log of 7, and that's going to be your answer for part A. Now, for part B, what you had is a little bit different. You can pass from logarithmic notation to exponential notation, or you can apply the e to both sides of the equation. Therefore, since you know that these two are inverse of each other, you can release the 2x minus 3 from the exponent and have the other side e to the power of 5. After that, you just solve for your x, having 2x is equal to e to the power of 5 plus 3, and then you divide both sides by 2, having that x is going to be equal to e to the power of 5 plus 3, everything divided by 2, and that's going to be your answer. Okay, so let's move on to calculus. Okay, so what we know in calculus is that the derivative of the exponential function d dx, e to the u, is going to be equal to e to the u du dx. What this means is pretty much that we're using the chain rule. Okay, so it's pretty straightforward. You are going to see it on this example. If I ask you to find the derivative of y equals e to the power of 3x squared, what you have is y prime is going to be equal to e to the power of 3x squared times the derivative of whatever you have in the exponent. In this situation, the derivative of 3x squared is going to be 6x. So that's going to be your derivative. You can rewrite it if you want. You know that multiplication is commutative, so you can write it like this. But if you leave it like this, technically speaking, you are correct. So over here for part B, we have y equals sine square of e to the power of x. You can also see this as sine of e to the x, everything to the power of 2. So here you can see that you are going to use the power rule and the chain rule. Okay, so you have that y prime is going to be equal to 2 sine of e to the x, okay, because this one to exponent 1, times the derivative of the sine, which is cosine, okay, of e to the x, times the derivative of the inside of the cosine, which is e to the x. And then you would need to take the derivative of the x, but you know that that's 1, so we leave it like that. Or you can leave it as this. This is as much as we can do for this problem, okay? That's what we have, okay? Hopefully you find this easy. Okay, so let's move on to more examples so you can see that it's a pretty straightforward situation here. So over here we have the natural log. So you have that y prime is going to be equal to 1 over whatever has the natural log inside, so 4 plus e to the 3x times the derivative of whatever you have inside. The derivative of 4 is 0, but the derivative of e to the power of 3x is going to be e to the power of 3x times 3. Okay, so technically speaking, what you have here is you have 3x divided by 4 plus e to the power of 3x. So you have all this equation. Okay, you could leave it like that, okay, but this one looks a little bit more condensed. Similarly, over here, you would tell me, oh, I'm going to do the same. Well, this one, there are several ways of doing it. So from Algebra 2, what you know is that this is the same as x cubed natural log of e. So you know that natural log of e is going to be 1, so therefore this is going to be just x cubed. Therefore, the derivative of this is going to be what? 3x squared. Okay? So if you take the derivative as it is, it would be the same and they would cancel. Okay? So for this problem, what you have is you can use properties of log first. Okay? So you can separate this as natural log of 3 plus e to the power of x minus natural log of 3 minus e to the power of x. Are we okay with that? So So then you can take the derivative of each piece separately. So you have the derivative of this one is going to be 1 over 3 plus e to the x times the derivative of this one. The derivative of that one is going to be e to the x. Then you have the minus there, so you have 1 over all of this, okay, times the derivative of the denominator, which in this case is going to be negative e to the x. Okay, so you can leave it like that, or you can condense it a little bit like this, right? This is as much as we can do e to the x. Well, no, we can do more, but I'm just going to stop there because there's a lot of stuff that we could do. Okay, we can have a common denominator, you know, a lot of things. So, but I'll stop there. Okay, so obviously you can do common denominator and you would have another thing. Okay. So let's move on to the next one. The next one that you have over here is y equals x squared e to the negative x. So what you're going to do here is clearly a product rule. Okay, you are multiplying the x squared and the e to the negative x. So you have the first one times the derivative of the second one, which is this one, times negative 1, plus the second one times the derivative of the first one, which you know that it's 2x. Okay, so after this, what you have is this is going to be negative x squared e to the negative x, and then you have plus 2x e to the negative x. Yes or no? So that's what you have. Okay? So given e to the power of xy plus x squared minus y squared equals 10, we need to use implicit differentiation to use dy dx. So what are you going to do here? Well, the first thing you need to recognize that you have an e and it has a product in the exponent. So what you're going to do is you take the derivative of the e to the xy, so it's going to be e to the xy times the derivative of the top. That is going to be a product rule. Okay, so what you would do is the first one times the derivative of the second one, which is the dy dx, plus the second one dx, which we don't put. Okay, and you have that. Then you move on to the x squared, which you know that it's going to be 2x, and then remember that implicitly you know that negative y squared is going to be negative 2y dy dx. Okay, remember that when we are taking the derivative of the y is when this y, dy dx appears. This is going to be equal to the derivative of 10 is 0. Okay, so as we were doing before, you are going to separate the basically the terms that have the dy dx on this side and the rest on the other side. So also remember that this guy distributes to here and distributes to here. So the first guy that has the dy dx is this one, and the second one is this one. So for this one, you have that it's going to be x e to the xy, which is this one, okay, minus 2y, close it, and then move the rest to the other side. This one goes as a negative to the other side, and then this one goes as a negative to the other side, negative y e to the xy, because remember this is distributing here. After that, you're going to divide both sides by this monstrosity that you are not afraid, because now you know that you can divide by whatever you have there. So you have negative 2x minus y e to the xy, everything divided by y, x e to the xy minus 2y, and that's your answer. Isn't that simple? Well, I hope that you find this video helpful. Bye.